Hello, this is Samir Ouchani, and from CZ Engineering School in Aix-en-Provence in France. And this work, it is joined with Dr. Moez from the Faculty of CSIT at Al-Baha University in Saudi Arabia. This work is about ensuring the correctness and modeling of intelligent healthcare management systems called medical cyber-physical systems. First, we will motivate our work and the proposed approach and how to model the medical systems and how to analyze them. And we conclude this presentation. So medical cyber-physical systems are complex, fully connected, and smart. So modeling them and analyzing medical cyber-physical systems is a hard task because it is large and complex. So we need a way to be sure that this system is correct automatically. So the existing solutions update only the existing deployed implementation. And most of the initiatives separate services and using data mining techniques to analyze them. So this work look to standard language and first order logic and mathematical expressions to model the medical CPS. And we add an authorization management and an analysis based on SAT solvers. The approach, it is based on a law that is based on SAT solvers. It takes the model as input as well as its property to check if it is true and if it is not, it gives a counterexample. First, we model the systems as a use case like this, where each actor has its related actions. A patient can be registered by medical staffs and IT staffs, where the doctor can prescribe the status of the patient and consult his reports. And each patient has a medical record that can be filled or updated only by the nurse, doctor, or smart object. So these cases are only allowed for signed in and authorized actors. Each role has its class. So we present the system as of service by this class diagram, where only the staff and the connected objects can fill or update the patient records. And when authorized, and each update of the medical record is updated, so it will be automatically saved in the medical history. And as well as the patient should have a holder to regarding his treatment. Okay, and then the sequence diagram shows how the user interacts with the application through the authentication process that can be granted by the server and checked by a verification process by relying on the database service. To enforce the security and the authorization process, so an access control diagram is proposed where it is based on which role the user has and explicit by a combination of permissions that are attributes assigned for each operation. So a user or a group of users can have multiple roles and permissions. So a law used in this to analyze this this model, it is based on first order logic and the relational calculus, and for the analysis it is based on SAT solver, and it is helpful to be used for data modeling and specifying class objects constraint and the relations, which is similar to UML class diagrams and using with OCL. The most important, the main important term of a law is signature. So a signature defines a set of atoms, and where sig declares the signature. Each signature represents a set of atoms. So this is, and extent denotes which signature is a subset of another. So a signature is the main component to declare an object in a line, and extend to make this how an object belongs to another object. And the fields here are relations among signature. That means the relations that associate these atoms or objects. So if a value in alloy is a relation, that can be relations, sets, or scalars of all type. Well, relations are first order logic formula. And here, for example, F and A are two fields with the same constraint that define this relation. For example, here, in patient, we have MR and you have medical record. So the field defined the relation. And to specify a property to check it, we have the assertions like this. And assertions state that the property that we expect should hold. And we write it assert A, F, and to check it, we write check score. Like this, and this. And the same for we have another. So these three assertions, this figure represents the checking result of the assertions. And for the simulation, we can run a predicate. So we can define a set of predicates and we simulate them, where a predicate is a constraint with 0 or more arguments. And here we search for instances of a predicate within a score, like here show for 40. So this is the example of the simulation of the previous predicate. As a conclusion, so we modeled MCPS, medical cyber-physical system, with standard language, and we reinforce their authorization, and we automate the analysis of what we have modeled. And as future work, we try to propose a meta model for medical cyber-physical systems, including the interoperability services and enhancing the analysis with deep learning. So thank you very much for your attending. And if you have any questions, so you are welcome to send me an email. Thank you so much.